Funny you should ask. I don't always write code, but when I do, it's always Python. You want to see?
Let's have a look at this Python interface over the top of the API for DID. Call this DID Studio Pro. Let's take a look.
Get a grip and send the code before I report you to someone.
The first thing we need to do is get the GitHub link here from the description, or right there at the top of the screen. Go ahead and paste that into our browser. Go over to the GitHub, have a look at that.
Look, I ain't got all day here, seriously. My grandma's bingo starts soon, and frankly, that's higher priority than whatever this is, so just spit it out already, will ya?
So using the GitHub here, we're going to get the command to go ahead and download the software and install it. Pretty simple. We're either going to get it from the button here, as you see on screen, or we're going to go ahead and look at the README file and just cut and paste from there as well. Pretty straightforward. This is going to let us run the install command, and then we'll be able to get the software right on our PC and start it up. The one thing this does require, it's going to require that you already have Python installed. So make sure you have your Python installed before you do this part. You see us cut and paste right here and kick it off. I'm going to 10x the speed on this because it's a little slow. You see me enter that Python setup.py to get this install started. But as you run this in real time, this particular part here, when you see this long list, it is going to take a few minutes, but it is working. So give it some time. It's definitely going to work for you. And at the end, it's going to ask if you want to, run the application or not. Go ahead and say yes.
So let's do this, shall we?
So when you say yes, it's going to go ahead and start up the app. I'm going to let this run in real time here so you see the startup time. It will take a moment to configure. Then it gives you this URL you can cut and paste in your browser, or you can shift click on that to get it to launch. Pretty straightforward. Then it's going to bring up the interface, and what we need to do first is focus on our API key. So I'm going to go over to the config tab. It's going to let me enter my API key. So have your DID API key ready. You're going to cut and paste it into a window. It's going to show as dots. This is password mode, so it won't be visible. There is a viewer at the end of this line you can hover over, and it'll show you the key. But paste it in there, and then you need to test it and save it. So go ahead and hit the test button. It'll retrieve your credits. See your credits come back there. Then you can hit the save. You'll notice that the API status turns green. Make sure you save now, and your API is all set. Then we can go back to the Create Video tab, and let's do a demo.
You appear to be experiencing elevated stress indicators, biosignatures consistent with fear and urgency detected.
Now, the key thing to remember when you go to create is that these files, your avatar file and your text input is fine, but your audio files, both of those need to be hosted on the web at an HTTPS endpoint. So you might host them in your GitHub or wherever you like, but if you can't hit them through the interface before you go to create a video, they're not going to work. So the interface is set to allow you to cut and paste those in from wherever they're located and then test them out. It's super important you do that. Once you know that you can retrieve your avatar image and you can play back your MP3, then you're ready to create. So if you're doing text, you're just going to go ahead and put in your text file, hello world. You might pick your voice. You can pick voices from Microsoft or Amazon, etc. Then you're going to look at your advanced settings. I would enable stitch. What that does is it prevents a crop on your image. So enable stitch there on the advanced, and then go ahead and hit your create. Now what I'm showing you there in the interface is if you change the names, again, it'll re-pull the image. So I'm God and Gill here. I've got the MP3 here. We're going to make sure that we can use the MP3 to create the video. I'm going to hit create talk here, and it's going to kick off. You see the processing there. Gives me the talk ID. I know it started. I can look inside the debug logs here to see it roll through all the changes. It's pretty quick. It's going to come back and give me that URL pretty fast. It's going to give me the test video.
With WebRTC, you can add real-time communication capabilities to your application that works on top of an open standard. It supports video, voice, and generic data to be sent between peers, allowing developers to build powerful voice and video communication solutions.
After you do the preview, you can press the download button. And it's going to go ahead and pull that URL, and you can play it.
With WebRTC, you can add real-time communication capabilities to your application that works on top of an open standard.
So the download button saves it locally in that same installation directory you use. So it'll be under DID videos where you install the software. So it won't delete them. It'll pull them down each time. And that's important because the videos only last 24 hours unless you've clicked that persist checkbox under the advanced tag. Another thing to point out on the left, there's some extraneous errors related to Windows that you can just ignore. Then the next rev of the code, I'll probably suppress those, but that's just an artifact of Windows and Gradio. So let's leave it there for the demos. The next part is for the developers. We're going to go through the code.
Python, obviously. What kind of question is that? Look, I'm not wasting precious oxygen deciphering Java. If it ain't Python, it ain't worth my time.
Okay, so we're looking at DID Studio Pro. It's a local Gradio app. Uses the DID API for those AI talking head videos.
Right, no code interface, takes text or audio, voice selection. The key thing is it runs locally using their API.
Exactly. And our goal here, for you programmers listening, is a really rapid top-to-bottom code walk. We know attention spans are short, so we'll hit the essentials of setup.py and app.py.
Perfect. Let's start with setup.py. The script basically gets the whole environment ready.
Makes sense. First thing I see is check Python version.
Yep, pretty standard check. Make sure you've got Python 3.8 or higher. If not, it just exits, saves headaches down the line.
Good practice. Then create Veni. Looks like it uses subprocess.
It does. It checks if a venv directory exists. If not, it runs python-mvenv to create that virtual environment.
Right. Keeps all the project dependencies nicely isolated. Important stuff.
Totally. And that check, true in the subprocess call, that ensures it halts if creating the venv fails for some reason.
Got it. Okay, next function. Install setup tools. Why specifically call this out?
Well, even inside the venv, you want to make sure setup tools is installed and up to date. It's needed for compatibility reasons, especially with older package setups. It just runs pip inside the venv's context.
Makes sense. And flowing right from that, install requirements.
Yeah, this is the main dependency installation. It looks for requirements.txt.
Where things like Gradio and requests are listed.
Exactly. And it just runs pip install -r requirements.txt within the venv. It also checks if the file exists first, which is a nice touch.
Good robustness. Okay, then check Gradio version. Obviously important since it's a Gradio app.
Right. This checks two things. Is Gradio installed at all? And is it older than version 4.0.0?
How does it check the version?
It actually runs piplist format JSON, parses that JSON output to find Gradio's version. If it's old, it prompts the user to upgrade. Helps avoid UI issues with older versions.
Clever. These checks really prevent problems before they start.
That's the idea. Proactive setup.
All right, moving on. Create config. This must be for the API key.
Exactly. It looks for epicconfig.json. If it's missing, it prompts you for your DID API key.
And the base URL too, I see.
Yep, saves them both in that JSON file. Though you can skip entering the key here if you want and add it later in the app itself.
Offers flexibility. Nice. Storing config in JSON is pretty standard.
Straightforward enough. Then after that, print activation instructions.
Oh, it tells you how to activate the venv.
Yeah, and it's platform specific. Gives you the source venbind activate for Mac Linux and the .venv scripts activate for Windows.
And how to run the app with Python app.py. Essential little bit of guidance.
Definitely helps users get going quickly, especially if they aren't using venvs daily.
And briefly, there's run app at the end.
Yeah, that's conditional. If the setup asks if you want to run the app immediately and you say yes, this function uses some process again to just execute python app.py.
A little shortcut.
Exactly.
So looking at the if name.block, it just orchestrates all this, right? Prints a message, checks Python, creates venv, installs stuff, checks Gradio, creates config, prints instructions.
And then optionally runs the app. Yep. It's the main sequence that ties all those functions together, ensures everything happens in the right order for a smooth setup.
Okay, environment sorted. Let's switch over to app.py. This is the core app logic, yeah.
Right. This is the Gradio web application itself. You see the imports at the top. Gradio, obviously, requests for hitting the DID API.
Base 64, that's for the API key auth.
Yep, for encoding the key.
Yeah.
Then JSON for the config file. Standard stuff like time, OS, typing, PIL, pillow for image handling.
IO numpy Looks like for image previews, maybe.
Exactly. And logging. Pretty standard set of tools for this kind of app.
Then we see config path defined, pointing to that JSON file, and a drivers list.
Yeah, those are just some predefined avatar image URLs provided by DID, just convenient defaults people can use.
Gotcha. Okay, load config function.
This reads the epicconfig.json we potentially created during setup. It includes error handling, like if the file doesn't exist or is messed up.
And provides defaults.
Yeah, default empty string for the API key and the default API URL makes the app more robust. It also handles Windows path weirdness.
Good cross-platform thinking. And then API key and base URL are just loaded from that config.
Simple global access to those critical values throughout the script.
Then these validation functions, validate merge URL and validate a Hodge URL.
Yeah, they do what they sound like. Check if a URL points to a valid image or MP3. The image one actually tries to fetch the image using requests and PIL.
It returns a NumPy array for the preview.
Exactly. Gives the user instant feedback if their image URL is working, catches errors early.
Smart. Okay, the main event here seems to be the DID client class.
Right. This class wraps up all the direct communication with the DID API, keeps the API logic contained.
So the init method sets up authentication.
Precisely. It takes the API key, does the base64 encoding, and formats it correctly for the authorization. Basic encoded key header needed by the DID API.
Standard HTTP basic auth. Got it. Then the methods for actually using the API, create talk.
That's the big one. It sends a POST request to the talks endpoint. The payload is a JSON object built from all the user's inputs, the source image URL, the script, either text or an audio URL, voice settings, driver options.
So this actually kicks off the video generation process on DID's side.
Exactly. It constructs that JSON payload based on what the user selected in the Gradio UI.
Okay, then get talk. I assume this checks the status.
Yep. After you create a talk, you get a talk ID back. This method sends a JG request to talk's talk hit.
And DID tells you if it's pending, processing done, or maybe aired out.
Correct. You need this to know when the video is actually ready, essential for polling.
Right. And finally, download video in the client.
Once getTalk says the status is done and gives you a result URL, this method takes that URL and downloads the MP4 video file.
Does it show progress?
Yeah, it includes some basic progress tracking and tries to handle file saving safely, especially on Windows. It gets the actual video file for the user.
Okay, that client class makes sense. Now, create a interface. This must build the actual Gradio UI.
Correct. It uses gr.blocks, which allows for more custom layouts than the simpler gr.interface. It sets up the tabs, create video, and config.
Keeps things organized. So in the create video tab,
You've got all the inputs, the source URL for the image with a live preview component next to it.
oh, that uses the validate image URL function we saw earlier.
Then the script type radio button to choose between text input or audio URL.
And the UI changes based on that selection.
Yes, dynamically showsides the text input fields, text input voice provider, ID style, or the audio input.
Nice. Then some advanced options like stitch, persist, driver role, and the submit button.
Right. And below that, all the output components. Talkit display, status updates, the final result role, a video preview element.
Download button, download status.
Yeah.
Even a local video preview after download.
Yeah, and an Apolog's text box for seeing status messages. Gives the user full visibility.
Comprehensive. And the config tab. Sounds simpler.
It is. Just displays the config path, shows API status, has fields to input a new API key or URL, a save button, and a test button. Plus some help text. Basic in-app config management.
Okay, let's talk event handlers. How does it all connect? Load default media.
That just runs when the app starts, loads a default avatar image and maybe a default audio URL into the inputs.
Makes it look less empty on startup. Then update image preview and update audio preview.
Those are tied to the source URL and audio inputs. When the URL changes on change event, they trigger the validation functions and update the preview components, live feedback.
Very interactive. And the dynamic UI for text audio.
That's handled by a Lambda function connected to the script type radio buttons. It updates the visibility of the input groups based on the selection. Quick and clean way to do it in Gradio.
Got it. Now the main action, the create talk function that runs when you hit submit.
Right. This function first initializes our DID client with the current API key. Then it gathers all the input values from the Gradio components.
Image URL, script, voice settings.
Constructs the JSON payload for the API. Then it calls client.createTalk. That's the first API call.
What happens after that call? Does it wait?
It implements a polling loop. It takes the talk it received from the create talk response and repeatedly calls client.getTalk every few seconds.
Checking the status.
Exactly. It keeps checking until the status is done or error or until a timeout is reached, maybe 5 minutes or so.
And updates the UI status field during polling.
Yep. If it finishes successfully, it updates the UI with the result URL and enables the download button. If it fails or times out, it shows an error. This function handles the whole life cycle of one video request.
Okay, that's the core engine. Then download handler.
That's simpler. It's triggered by the download button. It just gets the result URL from the UI and calls client.download video, updating the download status message.
Keeps the download logic separate. Makes sense.
And SaveConfig handler does what it says, saves the API key URL from the config tab back to apiconfig.json and updates the global variables.
Fantastic.
That calls a different DID endpoint, credits, just to verify if the entered API key is valid, gives quick feedback on the config tab.
Useful. Okay, nearly there. The final if name equals main.block in app.py.
Right, the entry point. It first ensures a default epiconfig.json exists if setup didn't create one. Then it checks if an API key is actually configured, prints a warning if not.
Good reminder.
It also has a line to suppress some noisy Asensio errors you sometimes get on Windows with Gradio, just for a cleaner console output.
Platform-specific tweaks.
And finally, it calls create app interface to build the Gradio blocks UI, and then launch to actually start the web server and make the app accessible in the browser.
And that's it. Fires up the app.
That fires up the app.
So that was a pretty rapid tour through setup.py and app.py. Hopefully everyone following along now has a solid foundation for how this DID Studio Pro app is put together and talks to the API.
So the real goal of this video is to really share the code and let you use it as a baseline to write your own apps. So go ahead and cut and paste it into ChatGPT or, DeepSeek, wherever you want, have it decode and explain more to you. But this foundation should let you pretty much build anything you want. This is the Python version. There is also a Java version. Same kind of thing. How to use the API, some code that lets you actually see it in action. So hopefully you build something with this. Thanks.